Cypress in the past, but I started using it on a daily basis here, and I sort of fell in love with the tool. And we do extensively use Cypress for component testing, as Akshay mentioned. And as part of this component tests, we need to test the front end in isolation of the back end. For a number of things, when we run our tests in our feature branches and the pipelines, we actually do not have a backend to talk to. So because of this, we need a tool which can mock the backend and mock it in a very flexible way. And that's where Cypress comes into picture. That is what the Cypress Intercept command does. And so I'll take you to this journey with me on what the Cypress Intercept command is, how can it help you write fast and reliable UI tests. So basically, this is what the agenda for the day is going to be. Instead of giving you a dry lesson into what the tool does, I'll take you through a real world sample application. We'll talk about all the test scenarios for it and the test challenges that we have. And I will introduce the idea of testing front-end in isolation. Maybe it's something that you have used in the past, maybe something that is new to you. So I'll try to spend some time on this because this becomes very important in testing modern front-end applications. Then we'll see how the Cypress Intercept command helps in testing the front end in isolation and writing then fast, reliable, stable tests. And then I will give you a demo of the application itself and the test cases. We'll walk through the test code and we'll actually execute our tests here. Now, well, it's a real world application in the sense that it actually works and it actually talks to an API in the backend. It's a Star Wars search application. What it does is you can search for characters or planets from the Star Wars galaxy. When you search for some text, you can either get no result, like this one, or you can find one result, or you can find multiple results for it. When you search for a person, you get a few items like gender, birth year, eye color, and skin color. When you're looking for a planet, then you get population and climate and gravity. So this was an application that I used to explain the concepts around it. It is actually deployed in the real world, and we will use it, and we'll see how we can test this application. What it does is it has in the backend an API that it talks to and fetches the data from. Now, under the hood, if you know, when you're talking about a browser, the browser has a section called the developer tools. In Chrome, we call it the Chrome Dev Tools. Firefox has its own, Safari has its own, even Edge has it. So what happens is when we run a search in this application, it makes a backend call. It makes what's called a request of type XHR. In this case, it's a get call to a certain endpoint. In this case, I searched for a person called Skywalker. So that's the endpoint that it called with the query parameter Skywalker. And for Skywalker specifically, what it gets back is a JSON object. This is a rather standard practice in most modern web applications. They talk to an endpoint in the API, and that API replies back with a JSON object. In this case, we get a key called count, which says it's 3. So basically, there are 3 results, and the results key has an array, and each array has an object for a person. Now, in reality, you get a lot of information for every planet or for every person, and you decide on the front end to only render a few of these details. This important information is very important for us to now go ahead and do the testing for it. Before we go ahead, Cypress is different from a traditional Selenium-based test tool. The difference here is that Cypress is aware of the network requests being made from the application. The traditional Selenium way is basically you act as an end user, you interact with your browser, and you observe what a normal user can observe more or less visually or on the DOM level. But this is a representation of the Cypress architecture. This green box here is the Cypress application, a Node.js application. When you ask it to run a certain test, it opens a browser. The browser has two iframes. One iframe has a Cypress test runner, and the other iframe, you load your application. What then happens is that if while running the user interaction in the browser, in your application, the application makes a network request, like the request we just saw in the previous slide, where it calls to the API in its backend and gets data from. All of those requests pass through a proxy in Cypress. Because of this, Cypress knows any and every request that is going out of the application to the internet or to your backend, and what responses are coming back from it. So with this, we can ask Cypress to do a lot of things when a request is generated from the application. And that's what you can do. So in this, you can use Cypress to inspect the outgoing request. So when we make that request for a person called Skywalker, you can check what URL was called, what parameters were sent to it, what was in the payload, what was in the headers. And you can do the same things with the response that your application gets back. You can check for the payload of the response, you can check for the status code, you can look at the headers inside. And another important thing is you can simply say, wait for the response to come back and wait for the response to be success, to be a 200 or a 2xx code. This becomes very important for end-to-end tests and making them stable. Finally, what you can also do is you can say, I don't want you to send this request out to the backend or to the internet, stub it. I want you to say, this is the response, something that I have already prepared in advance. When I click a button, that button ends up in a network call, stop that request from going out to the world, supply back this response. These are the three main things we can do with Cypress Intercept command. So let's talk about the basic test scenarios, what you can have from this application. And if you think that there is something I missed, just send me in the chat. You can search for a person or a planet. You can select the radio button and you can then search for the text inside. You can get 0, in this case, not found results, or you can get 1 result, or you can get more results. For Skywalker, we get 3. For a planet called UT, we get 2. And for Luke, we get 1. When you get the response, you display certain test data, certain information about the planet or the person, the character that we search for. It displays not found when no data is returned. And it's perhaps not very clear in this view, but it displays a loading message, a kind of a loader, when it is searching for the data and the data is not found yet. So those are the test scenarios I can think about. Is there anything you guys can think? Maybe you can put in the chat. Let me know. Okay, I'll wait for that. While we do that, we go further. Now, in this kind of an application, or well, in this case, let's say for most applications, the biggest testing challenge is test data management. When we are testing these things, now in my example, of course, when you look for Star Wars is a very small world. You have very fixed data. You can always find the data you want to test with. But in a real world application, it becomes difficult to set up your test data in the backend and to maintain it, to have it available in your pipelines, to have the right response time so that you don't have timeouts. And if your backend is very complex, like if you're in banking or in telecom, it becomes even more difficult to test these kind of things. Other than that, you can have a slow execution if your backend is slow. At the same time, if your backend is too fast, you can also have flaky tests. For example, that loading message you saw, it's possible that the backend is too fast, the response comes back. And then you may not ever see the loading message. So the application, the test application may never see that. Another issue is isolating the error. So if I run an end-to-end test where I type something, I search for it, and I don't get the right response back, where is the error? Did I make the right request? Did the backend reply with the right data? Or did the front end never display the right data in the right way? The error could be anywhere, but in a more traditional Selenium-based testing tool application kind of thing, you may never know exactly where the thing has gone wrong. Cypress, and with its intercept command, can really help us do that. Now comes the slightly, for me, it was rather new, let's put it this way. When I joined this organization, for me, this was quite an interesting concept. But that's something that we are now implementing in most applications, trying to test the front end and the back end in isolation before we go for an end-to-end execution. So this was a relatively simplistic application where we all know how the end-to-end testing works. We take the whole picture, the front end, the back end, and if there's any kind of middleware, we take that all into the context, and we say run end-to-end test. Fire something in the front end, wait for the responses to come back, and then check what happened here in the front end. What we are doing more and more now, especially in the modern front-end frameworks like we have React or Vue or Angular, we can test things in isolation. We can try to test the front end in isolation and the back end in isolation. But in this talk, I'm not going to talk about the back end. Let's try to focus on the front end where Cypress really shines. Although you can also do API testing with Cypress, but this talk is about the front end. So what do I mean here with isolated front-end testing? Simply consider your front end as the application. Your backend is an external service. We mock it. We do not send any responses or any requests to the backend. We do not request any replies from it. We control what we want in a test to happen. With this, we have a very deterministic test. So as I say, in testing, your test should be very specific to one thing and only one thing. And if that fails, you know what has failed. So I'm going to now show later which of these scenarios we try to move into the isolated version and which we try to keep in the end-to-end. So if we go further with that, well, before I go further with this, let's just come back to it. I want to check if there are any questions on this. If you have any questions, just shout out or write in the chat, because if this idea is not clear, I would like to clarify that before we proceed further.
I don't see any questions, Sandeep, yet. If it is there, I will try to respond and come back to you.
Okay. If this is clear, then let's go further. Now, what we would like to do in these isolated front-end tests is you have no backend, or you can just completely mock and stub the backend. We do not have any complex test data setup required. What we're going to do is we're going to mock everything. we're going to stop the backend responses. We are not going to go to a backend and check for the answers or check for the responses. With that, what we can do is we can execute a lot of scenarios in a very small amount of time. And end-to-end tests, as I hope we all know, they're the most real-world tests. They can be slow and flaky. We can reduce some flakiness using the intercept command, especially when it comes to backends. And so we'll try to do as few scenarios as possible. And if you think about it, it sort of fits that testing pyramid thing, where you have as few as possible end-to-end tests and more of lower level tests, which in my case, the isolated front-end tests are lower level. They are very specific and they are stubbing things. They are mocking certain parts of the backend or the backend completely. So that is the basic idea. And from there, I'm going to now take you to the actual test scenarios, how we can do. Now, we can have a scenario. Let's say we search for a person or a planet. At that stage, what happens is when I click the search button, I make a network request to the backend. The test is going to be simply saying, did I make the right request going out? So we are going to ensure the correctness of the request that is being made so that we know that the right request was made with the right parameters, the right query string parameters, or the right payload. The next scenario is you can display 0, 1, or more results. And for that, we're going to stop the backend response. We're going to just type anything in our search, and we're going to make sure that a request is made out. And then when a request is made out, we say respond back in one test with nothing in it, and the other one which has one response in it, and the other one with multiple responses in it. And this displays certain data when the search responses are retrieved. This is where we do the bulk of the testing for the component itself, that this component will display a name and then will display all the individual information there. You can check this in detail so that you know that this component renders the data correctly once it receives the data correctly. And for the loading part, now this is where it becomes really interesting. With Cypress, you can actually not only stub a backend response, but you can also insert a delay in it. You can even insert a fault that you have a network failure, you have a 404. So what we're going to do is we're going to slow the response down to make sure that our front end, the code has enough time to render that loader, the spinner, the loading message. And after some time, it actually disappears and the right data is displayed there. These are the kind of tests that I would like to now push towards the isolated format in which the backend data is completely stubbed out. And then you can always have a few end-to-end tests so that you make sure that your backend and frontend can actually talk to each other correctly. So now you can find one for when no data is returned, or you do find certain responses on search. Now, in this scenarios where Cypress helps is when you can say, I want to make sure that the request was triggered, and I want to wait until the response is retrieved from the backend. What you ensure is that the data is loaded. When the data is back, the front end renders it. And now you can say, yes, now I'll proceed further with my test. It is especially helpful with single page applications. Sometimes what happens is in the single page applications, you don't have a URL change. The page doesn't reload. It's just that some information gets re-rendered, and you need to know when that re-rendering is going to happen, especially with a slow backend or a backend that's under load. It could take a second, it could take 3 seconds, it could take 5 seconds. We do not always know. And that causes flakiness based on hard-coded waits and sleeps. What happens there is once this response comes back, certain elements are removed from the DOM and re-rendered. And if we do not know when that re-rendering is happening, we get detached from the DOM kind of exceptions or stale element exceptions. You can avoid those by waiting for these network calls. you need to know what your application is doing, how many calls it makes, or what is the last call that it makes. And once that response comes back, you then proceed further with the rest of the thing. When you say inspect certain elements or expect certain data to be on the screen. You can still have this test for that loading message or the loader to be appear. I mean, I've grayed that out because I don't really think you need to do that also in real life. But Cypress can also do this. Cypress can also actually take your request to the backend, wait for the response, but introduce a delay before it sends it back to your application. So you can also do, let's say, put a 2-second delay here, giving it enough time to check that the loader is there before it actually loads the data. Any questions?
Yes, there are some questions. The one question is about the pagination from Deepak. Deepak, would you like to elaborate your question? What?
Yeah, like in a case we are getting response which is not going to fit in a single page. So how are we going to test that scenario in front end?
Yeah. So let's say you have a pagination limit of 10 results. You actually get back, say, 25 of them. So now you have 3 pages. This is a really interesting one because you don't have to find the test data, which will give me, okay, this time it'll give me only 5 results. And for this data, I'll get maybe 13. So I see 2 pages. And then the next time it gets me 25 of them. So I have 3 pages. But what you can do is you can start those responses. And I will actually show you how it can be done in a demo with the real code for this scenario. So for example, you can say, I want no results, or I want 1 result, or I want 3 results. You prepare your data in advance. When you run your test, before you run your test, you say, when I make my call to the backend, reply back with this data. And you can also, in your pagination, you say, okay, I'll go to the next one. Now, it depends on your application whether it makes another call to the backend for that. Then you override the intercept command and say the second call should return back a different set of data. And then a third call will make another response back. So you can very clearly set up your test so that it returns to you the exact data that you want. I hope that was clear. If not, we can take it up after the session is over, or maybe it becomes clear to you from the demo because we are almost there.
Yeah, Sandeep. Yeah, we can see the demo.
Sure.
Yeah, sure.
Okay.
And sorry, for one more question I have. So can we test async call in front end also?
Yeah, this was an async call that we're making to the backend that we are here. And so that's what I'm going to show you. It's all async. XHR calls are async calls that are made in the front end. It could be a fetch call. It could be an XHR, any of them. Even the complete page load can be faked.
Okay, cool.
Okay. Cool. So I'm going to show you the most basic syntax for the intercept command, and then I will show you the code where it becomes more clear. The code is very simple. It says CY.intercept, and I usually use this format of the function. You pass in a method. The method is a string, a get, post, put, delete. The URL. The URL is a string or a regular expression. Cypress uses something called mini match. That is one way of giving it as a string which matches multiple things. You can give it a plain regular expression, or you can give it an exact string, in which case it will match the exact URL. The route handler is basically the code that will instruct Cypress what to do in case you get a request which matches this URL and a method. If you pass it a string, it'll make a JSON out of it and send back as the stub response. You can give it a JSON object, and then it says, okay, take this JSON object and send it. There is a more elaborate format called static response. It's a type, but usually what you do inside this is you give it a fixture file. Say, this is my file. It's located in a folder called fixtures in Cypress, and say, okay, when you get this request, please serve this file as the response. And you can also put in delays, or you can also stop this with an error in this. And if you want to do something even more fancy with it, you can pass it a callback where it gets the request object, and you can do a lot of things inside it with typical JavaScript stuff. I won't go more into this, but we'll just simply go to our, well, say demo. So this is my application, and in my network tab, I will show you. So if I'm looking for Skywalker, well, nice. And I search for it, I get this request. This is the AJAX call, the async call that is being made. And this goes to this URL. It has /API/people. So if it's for people, then it goes here. For planets, it'll be /planets. And what was my search parameter? The word that I use, Skywalker, is here. It is a GET request. So I know what will happen when I click this button. I want to make sure this is exactly what happens when I click this button. It makes this request and nothing else. And if I look at the response, as I showed you earlier, yes, it says there are 3 results and you have these 3 items in it. Now, if I search for something really absurd, which doesn't exist, there's a second call that has been made. This time, it comes back with an empty array. So I need to know these, and I need to create stuffed files for this with this data. And with that, I can run my tests. So let's try and see what kind of tests I have. Now, I hope you can clearly see the code here. I have closed everything off. We have the integration folder, which has my tests inside it. And the only other folder that really has something is the fixtures folder. Those fixtures folders has all the responses I want to see when I actually run my tests. In the isolated tests, as we saw in that presentation, we say, okay, it should trigger the search with the correct parameters for a people search. And the next test is the same thing for a planet search. Let's see in detail what we do. I'll come back to this a little later because that's the intercept command. What am I doing on the UI? I visit this page here. I make sure that this search card is visible. When this is visible, I can then interact with it. I click on the people radio button. I type in Luke in my query, and I find the search button and I click it. And that's something that you will see in most of our tests going forward. The action is almost always the same. What am I doing here with intercept? First parameter, method, get. I want to intercept a request only with the get method and nothing else. The next request is the exact URL I have here. In this case, I want to make sure that the call should be made to /API/people, and the search parameter should be Luke because I am typing in Luke here. It's possible that whoever wrote the front end could make a mistake and it may not send any item here, for example. In this test, I make sure that when you click the search button, you make a request which fits this parameters. This test will fail if something goes wrong with this or if this request is not made. At the end, I give it an object. This is the third parameter. This is this is an object in which you can have a few keys. The most important one is fixture. When I say fixture and I give it a name, the name is noresults.json. Cypress will look for a file with this name in the fixtures folder. It will find this file. The file here has an empty results, exactly what we saw here. This is the JSON. This JSON has input into this file, and now Cypress is going to serve you this file in the front end. The front end will react to this and will display no, not found in this case. The same thing I have done for the planet search. In this case, the difference is /API/planets. And in this case, I just keep the word Luke because I type Luke here. Now, I'm going to say, I want to check not found is displayed when no results are rendered. The test is exactly the same as above. I say Cypress Intercept, get. In this time, I have used this format of my endpoint. I'm not giving an exact endpoint. I'm saying anything that goes to /API/ and then whatever else at the end of this URL. Match that and serve me a file called no results.json. I do the same thing. I type in the word. In this case, I type in blah. I click on it, and I want to see no results displayed on the device. I call it no results as a test ID. It actually is not found. We inspect this. We get test data ID, no result. So that is my test here. I see that there is 0 return. Now, in the next test, I'll say 1 search result. And then in the next one, I say 3 results. So I have different files here. One file which has 1 result in it, this one with Luke's, and 3 results for the Skywalker example. I simply go forward with it. I say this time serve this guy. I make sure that 3 character cards are displayed here. So Skywalker results in 3 results. This one is a card. I say there are 3 cards in it, and the names should be these 3 items. The last one, that's a little more interesting one, where we say I introduce a delay of 2 seconds in the response. The difference here is the setup is mostly the same, except for a delay parameter called 2000. I introduce a 2-second delay, and after 2 seconds, you will see the results back. I set up with the 3 results JSON. I click on the search. I wait for the loader to be visible, and then it not to exist. And then at the end of that, we expect the data to be displayed after that message is removed. So I say I should have 3 cards here. This is my test suite for the isolated tests. I have stopped everything in the backend. I have slowed down the network request, and there are more things you can do with it for more complex scenarios. I'll very briefly go through the end-to-end test because there's not much is being done, except for you have an extra thing here. I say, I want to handle the GET request. I want to map it to this endpoint, and I want to call it search. Why I need to give it a name is because I'm going to now here wait for that network request. With this command, I will handle a few nice scenarios. One thing is I'll make sure that this request was made. Second thing is I'll wait for that request to be resolved. And third, I'll make sure that it actually resolves with a 200 or a 2xx response code. This will tell me for an end-to-end scenario that my whole communication with the backend went fine, and I did actually get some data back for it. And the next one will have something exactly similar. There's nothing special about it. It's just that in an end-to-end test, I need to know the exact test data. So I have to have my test data setup done, unfortunately. And this is the last one for the same loading message. Well, not leading, loading message. And I get the same GET request. And this is then the format in which you pass in a callback. You pass in the request parameter. And that I say reply with a response, but introduce a delay of 200 seconds. Sorry, 2 seconds, 2000 milliseconds. And in this case, you'll have the same thing happen. It'll slow down. The response will come back in 2 seconds, and then you will see the results. We use Skywalker as the search parameter, and hence you will see 3 cards here. Last but not the least, we will try to see how this actually runs. So I'm going to bring my Cypress runner in. Let's try to run the isolated test first. And unfortunately, they open in the wrong window. So I'm going to stop that and I'm going to start again. And here you see this thing comes up for 2 seconds before it goes out. Here we see 3 results. Here we see just 1 result at the end of it. We will see it exactly the way we have it. So in this case, we expect 1 result and we check for it to be male. In this case, you got 3 results and you check all the 3 names. And Cypress makes it easy to see what you tried to verify, where was it on the UI. And now I can run the end-to-end suite. And again, you see that loading thing comes up for 2 seconds before it goes away. So this is how we try to use the Cypress Intercept command to make tests stable, to be able to run tests without a backend. It is really useful when it comes to testing things in the CI pipeline, especially when you don't have your backend available to the pipelines. In our organization, we are developing a number of what's called micro apps. They have either just a front end or a front end and a middleware, which talks to a very big backend, which is not usually available in our pipelines or on our local machines. So actually trying to test them in the isolation, it actually really makes sense to test your front end and also in our case, our middleware, independent of everything else, and then put a few tests in the end-to-end to see that your interactions are all fine. That was my presentation, sir.